another big 3D printer, and this one is really heavy. So I might have to call on my elves to help me later. But let's give it a shot. Let's see how far I can get. So we have some acrylic panels here. This is the printer bed, and it's heavy duty, I'm telling you. They have some aluminum wraps in the box too. I'm going to show you in a second. Let me put this on the top of the other box first. This is the big aluminum wrap. I don't know what this is for yet. I'm going to put it aside. I will move all the foam first because there's it looks super heavy, a super heavy metal in the box. In here, there are just some 3D printed parts and a lot of filament. I'm also putting this aside. And they send a router, not sure why. Just put it aside. More filament. As usual, some tools along with the 3D printers. And in this box we have the cable, the spatula, and some bearings, maybe for the spool holder. Let's put it all aside. I don't think I can do it. It's way too heavy. But I could work on the other parts first. Okay, I would just leave it here. There's no way I can put that on this. So I'm going to get my elves to help me. Well, I have to keep going and see what I have to do next. Next, there is still something in the box. Next step, I am going to put the Z-axis in. Here there is this part. There is a groove here. Is it called groove? In Chinese, we call it 沟槽. I'll show you later. Or maybe you can see it from here. So let me get my screws first. I like this. The motor probably on this side. Because the screw goes in there. I see. So the longer screw goes at the bottom, and the shorter screw goes on the top because there's labels at the on the back. I have to call on my elf scan. Be right back. So the printer is a sample. It is heavy and it's rigid because they're using the 10mm thick machined aluminum plate. And on this end, there is a micrometer for adjusting Z-axis, and on the other end is the induction sensor. Now let's look at the top. There is a Raspberry Pi here. It is running AutoPrint. My friend Gina Hoske, she's the developer of the AutoPrint. I will let her tell you all about it.
Hi, I'm Gina Hoske, also known as Fusel, and I'm the creator and main developer of Octoprint. Octoprint is a web interface for 3D printers that allows you to control and monitor all aspects of your printer and the ongoing print jobs right from within any browser on your network. You can also create time-lapse recordings of your prints, and on top of that, there's also a fancy plugin system included that allows extending the core functionality in various cool directions. Octoprint runs basically everywhere, be it a cheap computer, like a Raspberry Pi, or that laptop you still got lying around. And it is free and open source software.
I'm going to put Gina's links in the description box. Please consider visiting her channel or support her on her Patreon. She does fantastic things for the 3D printer community. So underneath the Raspberry Pi, I don't think you can see it, there is a smoothie board for 3D printer controller. They also use it for CNC or laser cutter machine. I think it is a pretty good choice, but I'm talking to them about maybe using a Durab board. Maybe it's more suitable for this. After all, this is just a prototype. They are going to make some changes later. And here, obviously, they're using the power supply. But this one, at first, I thought it is stepper motor. Because usually for normal 3D printer, It is a stepper motor, but this one turns out to be servo. In the front there is the motor, and at the back there is the sensor. So with the servo, it always knows its position. I'm excited to see how it performs. And on the side, we have board screws instead of belts for X and Y axis. This is pretty unusual, but let's see how it works. All the parts here, it seems heavy, industrial, and good quality. I'm already connected to the auto print, so now I'm going to try to level the bed. Okay, I think this is level. Now I will load the filament. Now I'm going to set the temperature to 190. I think that's it. Let's fill in some filament. Okay, now it is coming out. So I'm going to use a test print from a friend of mine. Her name is Lydia. She's an amazing young lady and she has her own 3D printing channel. But like a lot of women in the 3D printing and STEM community, she just doesn't get the amount of traffic that she deserves. So I'm going to put the link in the description box so you can go check out and see what she has done. Now, I'm going to download her MakerCorn. This is the MakerCorn she used to test her printer. Now we're in Simplify 3D. I'm just going to drop that. It just dropped right in the middle of the build plate. Now the Lydia's voice is printed at 200%, so I'm going to do that, change it all to 200%, and it automatically scales that. I think this one needs support, so I'm going to check generate support material, and this is just from the MakerThink people, this profile. So as is, I'm just gonna use that, and it looks good. So the build time, it's 4 hours 15 minutes. I'm going to save the two paths to this because later I have to upload it to AutoPrint. Okay, I'm just gonna drag that G code right onto the auto print window. And there it is, MakerCon.gco. And everything seems right. So it has a big heavy bed, so I'm just gonna heat up a little bit first. I think that's a good idea. Okay, everything seems ready to go. Let's print it. Looks good. All these objects are printed at 0.15. It looks clean, and take a look at the benchy bowl. The layer line is fine, but I guess I could dial it in a bit because I'm using Simplify 3D. But the Maker Muse Torture Cube, it is a little bit stringy and there are some small blocks on the side. But for the first print, I think it is more than acceptable. So what's the verdict? There is no verdict. This is just a pre-production 3D printer. And the MakerThink company sent it to me so that you guys can see what improvement they can make and change. We've going through some discussions of what they can do to improve it. But as you know, I'm not super technical. They sent it to me so that you guys can see how it works and maybe give them some feedbacks. They respect the feedbacks from the community, unlike some of the Chinese company, they are not so responsive. But this one is, they're open to any suggestions. So I'm going to put their address in the description box. Feel free to contact them anytime and tell them what you think, what they can do better to improve it for printer in this class. And remember, if I can do it, anyone can do it. Please subscribe and see you all next time.